To day 5 lecture, Python libraries and deep learning setup. So I am your educator Suyesh. So we will be looking at what we have done till now. In day 4 lecture, we will first have a look. So we have completed with neural network structures, key components, and how weighted sum is calculated, and how basically Z is calculated by adding bias to weighted sum and then applying activation function to it. We have looked upon the layers in neural network input layers and then hidden layers in the output layers. And then we have also looked upon weights and biases. Forward propagation we have looked and we have just took a basic model and then we have just it is an example of forward propagation we have looked and then we have calculated the number of parameters in neural networks and then this was an example calculation and then we summed up our lecture. One thing which I told you that I will show you, like I just prepared here. So this is how the matrix multiplication. We already know that the equation is basically this is the equation which we had followed till now. So this is our equation which we have followed till now. But we will see that how in deep inside the system the matrix multiplication takes place. So this is our matrix of 3 cross 1. Sorry, pardon me. So this is our matrix of 3 cross 1 and this is our matrix of 4 cross 3. So there will be a matrix multiplication between them. So if we multiply W1x, so 4 cross 3, and then if we are multiplying with input 3 cross 1, so the output matrix size will be basically, so here's the matrix multiplication between them. So the uh, output matrix size will be 4 cross 1 and then we'll be adding this, so basically we will get the final matrix out of this. So that matrix will again be passed, that basically we will get Z which will be passed inside an activation function. So this will give us the final output. So basically X is our input feature, this is our input, and then we have a basically three input feature, three inputs, and then this will be multiplied by weight, which weight is having there is basically four neurons. You will be looking like this is our first neuron, then second, then third, then fourth, and these are basically the weights associated with the each input neuron with the other neuron in the hidden layer. So basically, this is our system, and then there will be a matrix multiplication in it and bias addition in it. So this is the same, basically the same this part we are doing, where there are three input and four in hidden layers, and how matrix multiplication is happening. So we can say like for our this basically for W1, W12, W13. So for this neuron, there is W1, W1 is coming from this first input neuron, then W12 is coming from here, and W13. So for this, we will be getting W11x1, W12x2, and W13x3. So we will be getting that thing in matrix multiplication, and similarly for other neurons, and then the bias term will be added accordingly. So B1 is the bias of first neuron of the hidden layer, and then this thing will be passed in this basically this. Uh, so this is basically the Z will be passing. Why it's not drawing? 1 second. So this is Z basically. So it will be passing, and then we'll be getting the output. There will be a matrix of the output matrix from after the inputs are passed from the hidden layer will be like 4 cross 1, and then Basically this 4 will be multiplied by then this there will again the weights here associated to the output neuron, and that will be like the next weights will be like if I add a page here, insert a blank page. So they like if I do here only, actually it added before. So like we get as I said x2, like if we suppose there is after passing from this is basically the after passing, like take it basically z. Hmm, 1 second. Like take it after passing fz basically, and the answer is like a b c d. So this is basically the 4 into 1 matrix thing, 4 into 1 basically, yeah, matrix thing, and this will be multiplied with the weights. So like the weights of output neuron basically. So here will be w dash 1, and then w dash 2, w dash 3, and w dash 4. So again, this will be the weights of each the weights basically the if I say the neuron, this is the weight W1, which W dash 1 associated with this output neuron. So basically the if this neuron in the first neuron of the hidden layer is associated with the output neuron, so there will be a weight which we called as W dash 1. If this is our neuron second and this is associated with output neuron, then we have W dash 2, and this is a third hidden neuron in hidden layer W, it is associated with output neuron, so there will be a weight which we are calling as W dash 3, and similarly for this neuron. So this we basically created here, and then there will be a again a matrix multiplication here between uh, 4 cross 1 and 1 cross 4. So the final, basically there will be also be a bias term. So if we give it a bias, so if we just multiply W1 cross 1, so there will be a single scalar, we can say scalar tensor kind of thing, which will be the final output bias B output if we say. So, so basically, if we do the final calculation here, why it's again and again zooming in. So Z dash, if we say, so W output kind of thing, and Z plus B. So it will be like uh, here we have 1 cross 4, and then there we have 4 cross 1. So matrix multiplication, the dimensions we will be getting is like 1 cross 1, and then we will be adding a matrix kind of matrix basically of 1 cross 1, which is single scalar term like in matrix single. So we will getting a final output of 1 cross 1, and this will again be passed inside an activation another activation function like f dash z dash, and we will get the final output. So if we just put if we these things we have done in a variable, so it is kind of a matrix multiplication. If we put on the values, we can calculate the final output if we have the known weights, and then if we have the known biases and the values, then we can the input values, then we can perform the matrix multiplication and get the answer by ourselves. So this have done by taking variables basically. So you can do if you just try, you can try a piece of code and get the weights, and then do hands-on, get the weights online basically in a Colab book or Kaggle, and then you can just try to do by your own hand-on calculation, and you will get the same answer. The same things will be done by this. So this which I wanted to show that how matrix multiplication takes place inside our system, and how things you were till now you were just knowing this equation, and you understood basically what was weighted sum and adding in how we are adding bias to it and then calculating the output after using the activation function, but you didn't know about what's going inside, how matrix multiplication is happening. So was the basic thing which I wanted to tell you in last lecture, but I couldn't because of the length of the lecture was just getting bigger. So just I wanted to show this matrix multiplication, how things are going inside our system. So this will help you to this will help you enable to understand how things are going. And now we start with our day 5 lecture. So basically in our day 5 lecture, Python libraries and deep learning setup, we will be looking at two Python libraries like TensorFlow. Again, it's zooming again and again. So TensorFlow, and we'll be looking at the PyTorch basically. So these are basically two very important deep learning framework, and they have many predefined libraries inside it which we'll be using. And then we also have pieces of code snippets which I will be providing you. So basically you will understand more about the different deep learning frameworks, and we can accordingly use. Maybe we will be using first TensorFlow for some lectures, and then we will shift to PyTorch. So you may get basically the idea of both the deep learning frameworks. So so we should begin with what with our day 5 lecture. So Python has become one of the most popular language for deep learning due to its simplicity and availability of powerful libraries. The two most widely used libraries for deep learning are TensorFlow and PyTorch. So, introduction to TensorFlow. TensorFlow is an open source library developed by Google for numerical computation using data flow graphs. So, what is data flow graph? I actually already searched about data flow graphs. So, yeah, TensorFlow data flow graphs. So I was looking basically on what is data flow graphs because it is very basic thing to sometimes you need to dig deeper into things, how things are, what is the basic differences between TensorFlow, how things have been concluded, how things basically how they developed. So I was looking at what data flow graph is. So basically, uh, there are nodes and edges. So nodes are basically representing the mathematical operations like addition, multiplication, and then there are edges. Edges are basically tensors which have metrics or maybe 2D tensor or 1D tensor. So there are just data input data or process data after any node. So like this, if we say. So there are nodes basically, and then we have tensors. These are the edges basically representing the tensors which are passed on to the next node. So there was a very, if I look at, yeah, this was a very good article which I found. So you should have a good habit of reading the article. So I just opened the article, and this is the Medium article which I read. So this was just article just basically told the same thing about what are data flow graphs. So basically, the data flow graphs contains uh, edges and nodes. Nodes are basically representing the different operations, and the edges are representing the basically the tensors which are moving like this can be the edges can be considered an tensor or input data, and these are the nodes are considered as the operations which are like addition, multiplication, or different operations like matrix multiplication or anything like that, and then the data is forwarded to next nodes. So this is how basically the basics of data flow diagram, and then I just looked at how to visualize. I will be adding basically the links of this thing, this article basically, and then you can look at what and how things are working in data flow, and like this will actually help you understand how things are and data are flowing. So there is a visualization tool whose link will again will be provided to you. So there was already a link in this article like this. So this is the TensorFlow graph visualizer. It is provided by TensorFlow only. So they provide us a dashboard like this. So main graph and then so basically these nodes represent the different operations, and the edges are here representing the data flow. Like it's in, if the arrow is pointing here, then it's moving in forward direction, and data is just processing after every nodes, after every operation. So you can just import these code, like if you can just try and run in Google Colab. I already ran this thing, but yeah, so I just ran these codes. So basically, if you run this code, you will get the basic ideas how data is flowing and how conceptual graph. Here it showed some error also, but you will basically understand how things are moving, like in this part of, no, this not this article, in this basically it tried they basically he tried to show us how the different operations, like you already know what is ReLU, fully connected ReLU, and fully connected ReLU. Here also ReLU activation function, the same one which you have already run, like rectified linear unit, and then we have convolution operation. This we will be studying when we'll be going to CNN part. So basically, these are the different mathematical operation, and these mathematical operations are represented in a computation in a basically data flow diagram or graph. So the same thing is just I showed to you that basically the TensorFlow has integrated a uh, method basically to represent or understand those graphs. So I will be basically providing the link of this article, and from here you can open the link of TensorFlow Graph Visualizer, and you can try it yourself. Here the code is basically based on Fashion MNIST dataset. So you can try different things from here, like different visualization tools are there. You can just try it on yourself. So, moving to our lecture part only. So, basically, I forgot where were we. So, TensorFlow is an open library developed by Google for numerical computation using data flow graphs. So, I was explaining you data flow graphs. And it is particularly well suited for deep learning applications and provides robust tools for building and training neural networks. So the key features are flexible architecture, allows for deployment across various platforms, CPUs, GPUs, and TPUs. High-level APIs, TensorFlow offers high-level APIs like Keras, making it easier to build and train models. I already told you about Keras, that how earlier Keras basically tried Keras was providing high-level API to make use of TensorFlow earlier, when because TensorFlow was very low level and it was hard to code on TensorFlow. So basically, Keras was providing high level API for better understanding and coding. And then now the Keras is basically TensorFlow and Keras are now integrated, and now Keras is making it easier to build and train models. So the same thing is written here. Extensive ecosystems with tools like TensorBoard for visualization. I think the thing which we're looking TensorFlow graph, and I think it is the same TensorBoard diagram if I remember. Hmm. Yeah, this is basically what we were looking is TensorBoard graphs, which will basically a graph visualizer. So you can look at this. So extensive ecosystem with tools like TensorBoard for visualization purposes, and TensorFlow Lite for mobile deployment, and TensorFlow serving for model serving. So you can try all these visualizer tools on the main documentation pages, or the basically the main key pages, like in TensorFlow, the page you can explore, and PyTorch page you can explore and look at the various visualizer tools or various tools provided there. You can just try them. And the basic TensorFlow concepts, tensors, the fundamental building blocks of TensorFlow. Tensors are a multi-dimensional array that can hold data. So basically, tensor are basically it can be a 0D tensor, which we can call as scalar. Then we have 1D tensor called vector, and then we have 2D tensor, like we are calling it matrix, then 3D tensors, and then 4D tensors. So basically, you have already read about what are tensors in our DS course, data science course. So in code also we will be looking at how different, basically I can say like this is our 2D tensor. This is basically I made prepared a code uh, collab book. So this I will be using it to explain. I think I have written about tensors. Yeah, creating a scalar. So basically, this is a scalar tensor 0D, and then we have 1D tensor like 1, 2, 3, and then we have a, a matrix like thing or a 2D tensor. So 1, 2. So if you can see like if we make a tensor like we have a 2D tensor and it is filled by in first row we have 1 2 and in the second row we have 3 4. The same thing is represented here, like in first row we have 1 2 and then in second row we have 3 4. The columns are like in first column 1 3 and then second column 2 4. So basically this is how we prepared the scalar which is 0D, and then vector which is one dimensional tensor, and then we have 2D tensor which we call as matrix, and this we have done using torch. So we are using PyTorch to uh, basically initiate this with some values which we have chosen, and the same thing which we have done with using TensorFlow. This will be studying. So basically, you got the idea of what are tensors and the graphs. TensorFlow uses computational graphs to represent the computation. Nodes in graph represent operations. So basically, this I already told. Node in graphs represents the different operations, and while edges represent the tensors. The operations can be of different types. Like in it can be of like convolution, like we are applying convolution, or it can be of basic mathematical calculation. So basically, it can be of any type, any kind of operations, or like if we are applying any activation function that can be also represented in basically nodes. So this was the basic TensorFlow concepts. Now moving further to introduction to PyTorch. Introduction to PyTorch. So PyTorch is also an open source library which is developed by Facebook's AI Research Lab, and it is known for dynamic computation graph. And look, we just need to know the basics of these, how dynamic computation graph and data flow, basically data flow graph, and how things are basically working, like eager execution. Now TensorFlow is using eager execution. Earlier it used static graph basically. So basically the key feature of the PyTorch is PyTorch builds graphs on the fly. It means like on the run it makes the graphs and making it more flexible than static graph libraries. The earlier versions of TensorFlow use static graph libraries, which used to just first it used to make graph, and then in sessions it used to run the graph, basically run the graph, yes. So they first make graphs, and then in sessions we give a session in which it used to run that whole graph basically. And in but in PyTorch, they are using basically dynamic graphs, which just build the graph on the fly, and it just keeps on running. So in later models of TensorFlow, they executed eager execution. They used eager execution, which also which is also based on Pythonic syntax. Like uh, here it is written that ease of use Pythonic syntax and design, which simplifies coding and debugging. So eager execution is also the same like in Pythonic context. So now TensorFlow is also using no, it is basically using eager execution, and the PyTorch is based on dynamic graphs. So this is just a basic thing you just need to know. You don't have to get deeper into it. Now the strong community support. Basically, PyTorch is used by researchers in research fields. So in industry also, like R&D labs, PyTorch is used uh, more than TensorFlow. So this was the basics of PyTorch. PyTorch concepts like similar to NumPy arrays but with GPU acceleration capabilities. So when we run our PyTorch code, you will be looking. you will get the answers in tensor. So basically, PyTorch returns the answer in tensor, but TensorFlow returns the answer in NumPy array terms. So tensors basically it returns in tensors because it helps in GPU acceleration capabilities and in auto gradients also automatic differentiation for gradient computation. It is written here, simplifying back propagation. So basically the tensors helps in loading the uh, gradients without losing them, which is later used in backpropagation. I think I have written it somewhere. Like, yeah, if PyTorch automatically converted tensors to regular numbers. So if the thing was like PyTorch gives the answer in tensor format, so if it gives the answer in regular numbers in scalars or in just in regular numbers, so it would lose the gradient tracking, making backpropagation impossible. So in tensors it is helpful uh, for PyTorch to not lose the gradient, and it also helps in GPU acceleration capabilities if the answer is given in tensor format. And if the basically if it is given in regular numbers, then it would slow down deep learning models as PyTorch wouldn't be able to optimize computation. So basically, giving in tensor format, the basic thing which we understood is helps in backpropagation and helps in GPU acceleration, increasing the GPU acceleration capabilities. So this thing you have to remember for PyTorch, and nodes represent mathematical operators. This is the same thing which we have done. Basic PyTorch concept. Edges represent tensors data. This is the same in data flow diagram thing. Graphs define how computations are executed in TensorFlow. A PyTorch tensor is a multi-dimensional array similar to NumPy array, but optimized for GPU acceleration and automatic differentiation. So just tensors helps in remembering the gradients for back propagation without losing them. So this was, I think, this part was basically of a data flow diagram, and then we have why not to convert tensors to numbers by default. This thing actually I added in the lectures, so you can understand why the if you will look at the code, the answers are coming in tensor format when we are using basically when we are using the PyTorch deep learning framework. But you must be knowing why the PyTorch is not giving the answers in regular numbers. So this you must know why it is not giving the irregular numbers. So I already told, because we don't want to lose gradient tracking, or we want a better GPU acceleration capability. So we should get an answer in tensor. You can basically convert them into regular numbers, but we the by default the answers comes in tensor format. TensorFlow originally followed a static computation graph where computation graphs was first defined and then executed. This I already told you. And in PyTorch is based on dynamic graphs which execute in the fly, which basically it's like just running in the when the code is run, it by its own it develops the graphs, not like just first we are defining the complete graph and then we are executing in session. In dynamic graph thing, it's the like PyTorch builds graphs on the fly, like it's building in the run only, and then executing it, and then just going executing and basically making graph and executing it. So it's moving in the fly. But in TensorFlow followed a static computation graph. But later versions allow for eager execution. Yeah, eager execution thing I already told, where operations are executed immediately, similar to PyTorch. TensorFlow automatically converts tensors to NumPy arrays, while PyTorch keeps them in tensor format for further processing. TensorFlow automatically extracts a raw value while PyTorch keeps results in tensors for gradient tracking. Gradient tracking because we don't want to lose the gradients, which helps in backpropagation. But even though TensorFlow prints the value directly, it still stores results as tensors. So basically, inside in TensorFlow, it is storing in tensor format, although it is returning in raw format or regular numbers. But inside TensorFlow, it has tensors they are present there. So basically, it might be giving answer in NumPy array format or regular numbers, but inside it has tensors running only. So this was the basic thing about uh, what is TensorFlow, and what is PyTorch, and how they are using it. Now we will move what is data flow graph. So data flow graph, I already told you. A data flow graph is a computational model used in TensorFlow where operations are represented as nodes and the data that flow between these operations are represented as edges. This approach makes TensorFlow highly efficient for distributed computing, enabling computations across multiple CPUs, GPUs, and TPUs. So, as I already told, like in data flow, basically first we have to define the diagram, and then we use sessions to run them. So the thing comes here. What are sessions? A session in TensorFlow is an environment that manages and executes operation in computation graph. Since TensorFlow 1.x used a static computation graph, sessions were necessary to initialize variables and run computations. But in TensorFlow 2.2.x removed the need for sessions by introducing eager execution enabled by default. So this is basically enabled. Like if you are using Collab book, it already had enabled eager execution, so you don't have to worry about that thing. This allows TensorFlow to behave like normal Python code, executing operations immediately. So now we move to what is dynamic computation graph. A dynamic computation graph is a type of computational model where the graph is built and modified on the fly during the execution. So this thing also I have told you earlier. This is in contrast to static computation graphs where the entire graph is predefined before execution. So basically we don't have to use session kind of thing here. The execution is basically happening. Basically, the graph is built and modified during the execution time only. So we don't have to worry about session or all those things. Built at runtime, intuitive and Pythonic, flexible for variable length inputs. So basically, these are the features about dynamic computation graph. So you can look all these features. So this was the thing which you may need or you may not need also. This is basically the things which I never encountered. Basically, I mostly used PyTorch, but I never encountered these the basic, very deeper things about TensorFlow and PyTorch. What you should remember is that the basic thing which you should remember that what is going inside, like which I already told that matrix multiplication is happening. This is also the part of last lecture, and you should know that where it is gone. It has gone. Yeah, you should remember why not convert tensors to numbers by default, and because that thing is giving you the answer. This is the visible things which are coming, like I'm using here tensor, basically the PyTorch, torch.tensor. So tensor is coming, so you should know why it is returning in tensor. So this thing, why not convert tensors to numbers by default, is important. You should know about it, and rest is just a basic description how things are working. So setting up the development environment is our next part of the lecture, and we will be then looking basic operations with Python libraries. So there are some code snippet screenshots are here given here, but I've prepared a whole collab book here for understanding. So there are different code snippets and comparisons between codes. The rest you should look on basically you should look on the documentation pages to understand. Like we will be looking at the documentation pages in this lecture also for some of our codes, so that you can just get an idea how to read the documentation. So we should move according to the lecture notes. So basically we will be looking at setting up the development environment. So setting up the development environment is basically we are making a virtual environment for a project. So what is a virtual environment? So like I will give an example. basically make you understand this thing with an example like we have two projects if I say. So if we have a project A and project B, one second. So we have project A and we have project B. Yes. So we have two different projects A and B. So it may happen that project A requires the same library of different version. So like project A requires a TensorFlow, but of different version, and project B requires a TensorFlow for different version, or any libraries of different of basically a same library of different versions. So this way, if we don't make a virtual environment for project, different virtual environment for project and different virtual environment for project B, it and load all the libraries in a global environment. So it may lead to a breakdown of the system or breakdown of the project because we will have a library, a same library for same version of library for project A and project B, which are basically not compatible for them because project A requires different version of the same library and project B requires a different version of the same library. So we basically create a virtual environment for A, like like suppose it is a dome. Basically, it is a dome in which project A, there's a different dome for project A and project B, and we install the required version of the library in A and the required version of library B, and which these domes are separated. They are not in intersection, they are separated. So suppose there are basically a dome like A and then like of B. So basically we will install all the library here of the required version of that project, and same goes with the B, that we will require the library of the required versions for the project. Like uh, project A may require different version of TensorFlow and project B may require different version of TensorFlow. Same with other library like Nibble or PyTorch or any like scikit-learn or maybe any kind of libraries according to the need or according to basically the need of that project or uh, so basically we are just creating a virtual environment. We are not creating a global environment because global environment may leads to some conflicts between the different between libraries, and it may lead to breakdown of the project. So just we make a virtual environment. So the virtual environment basically helps us not in getting conflicts between this helps not in getting conflicts between the project between the different versions of between the projects basically. So we are just making a virtual environment for project A and installing all the dependencies or all the libraries according to the version of or according to the uh, project A's demands of versions, and similarly we are installing the dependencies and libraries for B according to the required versions of B, and then we just if you look at GitHub or any repository, you will be getting a requirements.txt where the versions, the libraries and their required versions are given by the developers. So you will get the idea how basically they give you the versions and libraries and then versions so that it may be helpful you during running of the program, running the baseline code in your system. So this is how the we this is basically the gist of what is development environment or virtual environment. So prerequisite Python ensure Python 3.6 or later installed. You can download it from official website. Package manager for Python. It typically comes with Python installation. So basically there are installation guides, installation steps to create a virtual environment. optional but not but recommended, because uh, if you have installed all the things in global pack all globally, all the libraries and packages, then the same thing that the conflict between the different versions, or different versions basically will occur, which will hamper the projects accordingly. So you should it is recommended that we should create a virtual environment to keep dependencies required by different projects in different places. So the same thing is written, creating a virtual environment that keep dependencies required by different projects in separate places. Use the following command to create a virtual environment. So accordingly, you can make a virtual environment in your local device. If you are using Windows, then you should use this snippet, and if you are using Mac OS or Linux, so you can use this, and then you can basically install TensorFlow can be installed, pip install TensorFlow, and PyTorch can be installed using pip install Torch Vision, Torch Audio. So you must be thinking why we haven't installed here. So basically, in Google Colab, PyTorch and TensorFlow are already installed. We are just importing them. So we can verify installation also. So after installation, verify the libraries are installed correctly by importing them in. You can run this code. So if I ran this code. So if again running this code, you will get the versions of TensorFlow and PyTorch. So basically, the key point to remember here is that creating a virtual environment keeps dependencies required by different projects in separate places. So this helps us avoid the dependency conflicts between the projects. Now we'll be looking at basic operations with Python libraries. So by looking this, you will understand the basic. You'll get the basic understanding of both the libraries, so that we can later on move forward with our deep learning codes and use these libraries in different codes for better understanding. Complete the last part of our lecture. So we'll be looking at some basic operations using basic operations with Python libraries. So we'll be using TensorFlow and PyTorch. So some codes are also present in the notes, so you can try them by yourself. And I have prepared a separate Colab book for running code. So basically, we'll be doing a problem with two types, basically using TensorFlow and PyTorch for better understanding. So first thing which I want to tell you is that TensorFlow and PyTorch are already downloaded in Google Colab. So just we need to import these TensorFlow and PyTorch, and then we have to run the code basically. And we have here we if we go here, so I've created a tensor. So tf.constant basically. So here, if you know Python, if you have studied Python, you must be knowing that we have here created a 2D tensor. So basically, it is a matrix, and then we are using tf.float32. So in data type, we basically d type is a data type. So it is an attribute inside constant function. So this we can call value, and d type is the another attribute. So we are using 32-bit floating point number here. So I think this is also a default data type. Like if we want for high precision, we can use 64. So basically, we are just first creating a matrix, and then another matrix of tensor, basically a tensor B, another matrix, and then we are using tf.add. So this function is basically used for adding, and tf.multiply for multiplying basically. The point in multiplication, you need to note that here we are doing element wise multiplication, not matrix multiplication. I will run the code for matrix multiplication also. So anyways, if tf dot addition, you must be knowing how matrix addition happens. So for like it's a 2 cross 2 matrix. So 2 cross basically 2 cross 2 matrix. And same for this also. So basically, it's a 2 cross 2 matrix. So if I try to code another similar thing basically by ourselves, so tensor is equal to tf dot constant, and then what we can do, here it has suggested These are the different attributes. So if first I write the value like I want to write 3 comma 4, and if I extend it to like this 7, and then I just pass the type as so basically here we just made uh, basically a 1D tensor. So like see a suggestion has came to us. So basically Google Colab uses Gemini, which predicts what code the user wants to type. So it suggests it, and by pressing the tab key. So here accept, we can accept this code by pressing the tab key it suggested. So if I press the tab key, then it completes the code. Look, it has completed the code. So here bracket was missing. So you can do this if it suggests you can, if you want that thing. So you don't have to manually type whole thing. So if I run this code, so yeah, so it gave the like I already scored it is a 1D tensor which I am passing as a value. So the shape, yeah, so the shape suggests the shape is coming in a tuple. So the shape suggests it is a 1D tensor with 8 elements, and you can look that there are 8 elements with data type of float 32. So basically this is how you can study like if you use the constant function tf.constant, and then you got the thing like there is a box which suggested different attributes, or if it isn't coming, then you can just go to the documentation, and if I write constant, and if I click enter, so it's opening. Let's wait for a few seconds. Yeah, tf.constant, if I open, yes. So the same thing is basically coming here. So value, d type, shape, and name. So these are the attributes. You should read this documentation to better understand everything. And now if I move again to the code, like if I try to do more things on this, like if I try to use shape attribute and pass this like shape, I have to pass in tuple. So if I pass it like 2 comma 4. So there must be 2 rows and 4 columns, so it will be written a matrix. Yeah. So 2 rows and 4 columns, and if I do like 8 comma 1, so it will be like 8 rows and 1 column. So basically we can do this thing. And one more thing which I would like to show, like if I have passed a 1D tensor, I can get a matrix by like typing. If I copy this thing, so if I copy it and paste here, and if just passing it 1, 2, 3, comma 4, and then I can give the basically I can give change basically I change the value by giving the shape. So if I do 2 cross 2, we already know the thing which we passed here is like a 2 into 2 matrix. So if I print, it will suggest, I hope, print. No, it's not suggesting. Sometimes it doesn't suggest. So tensor A will be typing it by ourselves. So the shape, I hope, yeah, this is same thing came here like 1, 2. So we can do we can get this by passing the shape. If we are passing it in a 1D tensor and we want to get a matrix, so we can do the same by by writing the shape by using the shape attribute. So this is the uh, this thing which we have done, can be done like this also. And we can perform tf.add. So if I open the documentation page again, and I write add, so it will give us basically, if we look at the search results, so tfmat.add. So if I directly write tf.add, it's running. Tfmat.add. Basically, so something must have updated. So let's look. It's opening. Internet speed is a little slow, so let's wait. So I think it opened. So tf.add. So if you look 1, 2, 3, 4, 5, and then TF dot insert shape 5. So basically there are five elements. It is a 1D tensor, and then it's a normal value, regular value. Uh, so basically, if tfmat dot add, so it will add it returns x plus y element wise. So it do simple basically addition, and if I run the code using tfmath.add, let's see if there is any problem. If it's working fine, then it's great. So if I copy and just paste it here and used, because I always did tf.add, so if it's working, uh, let's look. Yeah, it's working. So if we print, sorry, print add result. So yeah, it's same basically tfmat.add. So it's the same thing tf multiply. So basically, I think we are importing some math where basically there is a documentation of math, and inside it there is a add thing. So it comes under basically basic mathematical operations. So we can just like here it is tf.math. It's coming. Everything is coming inside tf.math. So we can use it basically, and like for multiply also I can, if I look here tf multiply, so it's opening again. The internet speed is little slow, so we have many different mathematical operation which comes under tf.math, and then we have tf.keras which have different. So basically we can we can just try to use any, we can use anyway because both thing is working, so we can use anyway. So it comes under math multiplication. Every mathematical operation we can look is coming in this left side list. You can see it's coming in tf.math. So you can try using them and do different mathematical operation. Tf dot multiply, it's basically, it's like scale, basically element wise multiplication. So it's not a matrix multiplication, it's element wise multiplication. So if I just look at basically if we look at here, so 5 multiplied by 1 multiplied by 5 and 2 multiplied by 6, 3 multiplied by 7, 4 multiplied. It's element wise multiplication, not matrix multiplication. So it's like 1 multiplied by 5, so 5, 2 multiplied by 6, 12. You know basically know the basic uh, element wise matrix multiplication. So basically, so this is the basic code which we have done using uh, TensorFlow, and if we look at different other types of mathematical functions, we can get like we can get also tan, square root, and all. And if I try to get matrix multiplication. So let's see what's coming. TF that. Let's look. So this thing comes under linear algebra. So this is basically lin ALG is linear algebra. So TF dot linear, or we can also write, I think I have done already done mat MUL also works. So if we just go there and just try to do code, uh, print TF dot mat MUL, and then just pass tensor A and tensor B. So it's all automatically suggesting. So if I change it to tensor B and just try to print it, yeah. So we basically get this is the matrix multiplication which we get. So we can do this. Uh, You can try doing this basically by yourself, and you will get the idea how things are working, how we can. If you fail to understand, then you just go to documentation page and try to do different mathematical operations by just applying some, just by taking few examples and trying to apply and implement these things. So basically, this comes under linear algebra. You can also use these other functions to do it by yourself. So this will be very helpful in future when you do different big kinds of programs. So this is the basic thing which I told you. We used TensorFlow, and similarly, I don't need to explain much about PyTorch. The same thing which you will be doing using PyTorch. So here also we will you will be just opening the PyTorch, basically the PyTorch documentation page, and then you will be getting the operations which you will be doing, and you will be getting the answer. So the similar thing, by we will be first importing a torch and then torch tensor. You will be passing a tensor, and you will be doing the same thing. You just try to read the documentation pages, and you will understand everything. You don't have to go anywhere. You just open the documentation pages, look at different operations, and try doing on the Google Colab. You will understand everything. No video will tell anything. If you just try it by yourself and practice it, you'll get the whole idea behind it. And see, I already told that it returns after using PyTorch, it returns the tensor. So I've already given the idea why it returns in tensor, why not convert tensors to number by default. So basic idea which I have given in earlier part of the lecture, you already know. So this is how PyTorch gave the results in tensor. So you got the idea what is basically behind everything. Here we are basically adding, so we just used addition operation, and we also use multiplication. So here we are getting element wise multiplication. You study the documentation, you will know how matrix multiplication will happen. And similarly, like again, we are just converting it to NumPy. So some tf dot add, we are just this is how we can basically dot numpy to convert a TensorFlow to basically in NumPy. So I will run the code and you will get the answer. Reduce mean a NumPy. So we are just calculating the mean. So 2 plus 3 give us 5 and divided by 2. So we just got the mean. So this is also the function you can see. Look in the basically you can look here. If I write reduce mean. If in mathematical function, if I try here also, uh, df dot math, if we look, yeah, you will understand how to use the documentation page, and you can read here how things are working. So similar thing we have done. So no further explanation needed. And similarly, you can open the documentation page of basically PyTorch and study. So basically, it's the same thing. And then we have again imported. So basically, no need to import once we have already imported, but it is written. So tf dot constant 5. So you already know this is a scalar term, and if we have a one bracket, so basically. If it is given a one bracket thing, so it is a 1D tensor. If two bracket here it is given, so it's a 2D tensor. So this gives us matrix 2D tensor, basically 2D tensor, or we can say matrix. So the matrix shape is basically 2 cross 2. Similarly, it's a 1D tensor and it's a scalar term. So basically, we converted it into basically scalar dot numpy, and we got the answer basically. So same thing which we can which can we can do. So basically here we are getting the tensor thing because as earlier I told in the earlier part of the lecture, so it returns basically PyTorch result returns as a uh, tensor basically. So we have done this thing. And see, matrix multiplication is done here also. And determinant is also calculated using the linear algebra and dot determinant, and transpose can also be calculated. And then the inverse also can be calculated. So basically, this thing is done this way. So let's move further in using how the things are done in the PyTorch. So in PyTorch, these things are done like this way, like a torch.matrix multiplication. So it is kind of similar, and in transpose, equivalent to torch transpose. So basically, this again you can read in the. I can just run and show it's nothing to tell because you already know how by hand inverses perform, how determinant is calculated. You just need to know the code. So basically, if you read the documentation, everything will be sorted. So if using basically NN for neural network, tf.nn.relu. So basically, in this thing, you are just uh, applying activation function. You already know how ReLU works, how sigmoid works, how tanh works, and similarly in torch also. Computing gradients basically you here it is already given y is equal to x square plus 2x plus 1, so dy by dx is 2x plus 2. Just we have differentiated by x, so here our dependent variable is y and x is the independent variable, and then we just uh, put the value 3.0 in x and just calculated the gradient. Similarly, we have done this thing with basically the torch requires grad plus 2. Basically, we are asking, there is a whole documentation page why we are using requires grad true. If you want, you can study by it yourself, or if you comment, I will make a lecture like how we are freezing the gradients and how we are zeroing all the gradients. So basically, this will take a short lecture. So if you want, I can teach you basically. So we can complete that thing in some another, not in that lecture, in different, not in this series, but some extra lectures which I can teach you. And similarly, we can reshape using tf dot reshape, and then we can access 0. So we can just pass the different attributes. So if you again read here, go at the different places where you want like tf.expand, tf.reshape. So I think it will also come in basically maths or linear algebra thing. So you can just look here, and or you can search and then just read it and apply. It's very simple thing. Same goes with PyTorch, the similar thing which we are doing. So if you have any problem, you can just type in the comments. So I would like to wrap up this lecture. So if I tell I just want to complete this. So it's a random number generation basically. And here basically it's normal distribution automatically. I think it's producing normal distribution, and here we have to pass it like in normal distribution we have mean at 0 and standard deviation as 1. So basically both are producing no, random numbers in normal distribution. So I think in basically we have to pass an attribute in basically in the TensorFlow thing, and it's like a default I think in Torch. Even I have to read the documentation for this. So we it's best to rely on documentation and read and implement. Sometimes you can use ChatGPT too. So basically you will understand. Similarly with softmax. Softmax is also an activation function which I already told to teach you in later lectures. We'll be doing a whole dedicated lecture on coding lecture on basically multi-class classification. So let's wrap up today's lecture. It's better to wrap up, and I would suggest to I will add the documentation pages link and just try to go and read the documentation pages. I will also and give that tensor board basically the data graphs where you can try that tool visualization tool. So it will be very helpful. This collab book will also I will provide, and this will be also very helpful for you. So let's just recap one. So what we have studied, we just got the intro of TensorFlow and PyTorch. What is data flow graph, dynamic computation graph? We also basically tried what we know now. We know about what is virtual environment and how to just start that virtual environment. So this is for local device.
how you can, like, if you're using basically if VS Code, you can how you can make virtual environments so you can run these codes and try, and then basic operations with Python libraries. So let's complete. Also, we have done some part of the previous lecture. Like you already know the equation, but I told you how inside the matrix multiplication is happening and we get the result. So let's wrap up today's lecture and goodbye. See you in the next lecture.